Welcome to the fourth and last step of the training on the CMEMS biogeochemical products for the Baltic Sea. In the three precedent notebooks, we first learned how to plot maps of biogeochemical parameters from the monthly CMEMS products for a selection of dates, for a regional zoom, and for the whole period contained in the product. Then we saw how to plot time series of the biogeochemical parameters at different points from the monthly CMEMS product. And in the precedent video, we saw how to plot vertical profiles of the biogeochemical parameters at different points from the monthly CMEMS product. In this last step, we see how to plot vertical profiles of the biogeochemical parameters along sections from the monthly CMEMS model product. As usual with Python, we first need to import all required modules. We will need the OS, NumPy, Xarray, and Matplotlib libraries. Let's import them. In this notebook, we are going to work with the two same files as in the previous video. One file containing the bioparameters on all depth levels, so the 56 depth levels, for March 2017 in the Baltic Sea. The other file contains the same parameters for June 2017. So the objective of this exercise is to plot the vertical profiles of the biogeochemical parameters concentration along sections for two different periods. So March and June 2017. Between point 1 and point 2 in red, and point 2 and point 3 in green. First, as usual, we need to select the NetCDF file and the variable name. We define the root path variable, which is the directory where our data is stored, and two variables, fname1 pointing to the file for March 2017, and fname2 pointing to the file for June 2017. We'll have a closer look on chlorophyll and oxygen concentration, and nitrate and phosphate nutrient concentration. We create a paramname array to store the four variable names in order to be able to loop over them in the next cell. Let's execute this cell. Then, as we did in the previous notebook, we open, read, and store the variables of interest of the NetCDF file the same way it was done in the previous step. So you can see that each file contains one time frame, either March 2017 or June 2017, and all depth level. Now we are going to generate, show, and save the section plots. So to draw a section between 2 points, we need to define long PT and lat PT, the longitude of the starting ending point of the section. So we'll have a closer look at the section defined between point 1 and point 2. But you can do the same exercise between point 2 and point 3 if you want to. You just have to comment these two lines and uncomment this line. Okay? And so we need to define the long section and lat section arrays which define 100 points evenly spaced between point 1 and point 2. Then we create 4 arrays per file. So 1 per variable we want to study. And these 8 arrays are of size 56 lines, 100 columns. They are initiated filled with zeros, but then we loop over each point in the section, and for each file we select the closest point in the CMEMS product, the closest point to the point of the section we are currently looking at. And then we fill each column of the array with all depth level we have extracted with the cell function. And then we create a list containing all the parameters for each file. Let's execute the cell. So here we just wanted to check that the variables are of size 56 lines for all depth level and 100 columns for all the points along the section. Now let's plot these sections for the 4 parameters. So the following cell creates 4 figures, 1 per parameter, with 2 subplots on each figure. 1 subplot per file or date, because 1 file contains 1 date. For each parameter and each date, it will then be possible to see the evolution of this parameter concentration along the defined section. So we loop on the parameter. So for each parameter, we create 1 figure with 2 axes. And then on the first axis of each figure, we plot the profile of each parameter along the section. Long section is the x-axis, and the depth levels are the y-axis. And on axis 2, we perform the same operation, but with the second file, so for June 2017. And then we set all the figure and axis properties as usual. So you can see that on the first figure, we have 2 subplots, and we plotted the chlorophyll concentration along a section. In March 2017, the chlorophyll concentration is pretty low, whereas in June 2017, you can see that the upper layers of the Gulf of Riga are experiencing an algal bloom. And we find the same type of figures for the 3 other parameters: oxygen, nitrate, and phosphate. So this is the end of this step of the training and of the training session on CMEMS biogeochemical products. I hope that you enjoyed following these videos and that you have learned how to manipulate and explore the CMEMS product. Plankton, whose concentration is much higher in the upper layer of the Gulf compared to March 2017. This has a direct impact on oxygen concentration. While the oxygen concentration is rising in the upper layers of the sea due to photosynthesis, it decreases dramatically in the lower layers, where the dead phytoplankton cells sink and are being decomposed by bacteria, consuming much of the oxygen dissolved in the seawater. So this was step 3 of the training. Now let's move on to the fourth and last step of this training session.